Assalamualaikum and hi everyone. So for chapter 6, we are going to learn about the network architecture, in particular the VPN, which is virtual private network, and also NAT, which stands for network address translation. Recall that in previous chapters we have learned about network layer in TCP/IP for IPv4 as well as IPv6. For this chapter, we are going to learn more in details about some of the options or some of the technologies offered in IPv4 as well as IPv6. Okay, so we are going to look at the differences between internet, intranet, and also extranet, the differences between private network and hybrid network. Okay, and we are going to learn into details on the technologies, for example, virtual private network as well as network address translation. Okay, so for the internet, we have learned so far about the internet in terms of the TCP/IP. So the internet is not actually a network, but it is a vast collection of different networks, okay, that use certain common protocols, which we have also learned, and provide certain common services. Okay, it has a worldwide connectivity, and the users in the internet are connected to the ISP. So ISP here stands for Internet Service Provider. Okay, and large ISPs have their own worldwide backbone networks, okay, which consists of leased lines interconnecting routers, while smaller internet service providers have peering agreements with large ISP to transport wide area traffic. And for the internet, most traffic are to or from outside networks. Okay. However, for the intranet, it is not worldwide connectivity. It is only internal internet protocol network, and typically accessible only on company premises or from company notebooks. Okay. It is actually a company specific private network that is based on internet technology. Okay. And it is a form of local area network. It works the same way as the internet. Okay. However, one major distinction between traditional local area networks and intranets is the reliance of the intranets on the TCP/IP, packet switching, and also internet technologies. It has, however, connectivity to the internet via network address translation, application proxies, firewalls, and also gateways. Okay, so it is often used with the private address range, right? So in the case of the internet, the technology is deployed over a public network, while for the intranet here, the technology is deployed within a private network, right? And extranet here blurs the line between the internet and intranet, right? It is actually extranet extends the company's intranet out onto the internet to allow selected customers, suppliers, and mobile workers to access the company's private data and application. Okay, basically it is making intranet available to selected external customers via internet, right? So some resources may be accessed by specific groups of users outside the organization under the control of network administrator. So for example, the usage of extranet, an organization may allow authorized customer access to product specifications for online shopping, and also availability, and also online ordering. And another example is distance learning in the university or the college, where student can access to the computer lab after password have been checked. Okay, there are some of the example. For any organization that needs privacy when routing information inside the organization, they can use a private network. Okay, so in private network, transaction between the people in the organization totally remain within the network, okay, which is secure from outsiders. Okay, and if you look at this example, different sites here, site A and site B, can be connected using routers and also leased lines. Okay, a larger organization with several sites can create a private internet, and the local area here, at different site here, as I said, can be connected using routers and also leased line. In other words, an internet can be made out of private local area networks and also private wide area networks. Okay. So in this situation here, organization here has created a private internet which is totally isolated from the global internet. Okay, between communication between end-to-end station here at different sites here can use the TCP/IP protocol suite. Okay. However, there is no need for the organization to apply for IP addresses within this with the internet authorities. Okay, to be used within the network, because they can use private addresses. Okay, they can use a range of private addresses which have been allocated for private network. Okay, for private network, three choices are available. First, network can apply the set of address from the internet authority. Okay, and when they apply for this set of address, they can use them without being connected to the internet. Okay, one of the advantages of this strategy is, in the future, if the organization needs to be connected to the internet, it can do so with very easy, because they have been allocated a set of addresses from the internet authority. However, the disadvantage is the address space is wasted. Okay, because not all private network wants to use, not all users in the private network wants to use or want to be connected to the internet. Okay. The second choice here is to use any set of address without without registering. So this is okay because the network is isolated. Okay, so because the network is isolated, the addresses do not have to be unique. Okay, it means that in another network which is far away, there will be a user which use the same address as this user, okay, in this private network. However, this strategy has a serious drawback, because users might mistakenly confuse the addresses as part of the global internet. And the third choice here is to use the reserve address. Internet authorities basically have reserved three sets of addresses to overcome the problems associated with the first two choices here. Okay. Okay. So any organizations can use this reserve address without the permission from the internet authorities, because everyone knows that these reserve address are for private networks. So the range of the the range of the reserve addresses are as shown here. Basically, this range are unique inside the organization, and also they are not unique globally. Okay, unique inside the organization means that one user within the organization is allocated one address from this range. Okay, from any of this range, and one address here cannot be used by more than one user in this organization. However, the same address can be used by another user in another organization, which is considered another private network. Okay, so if you see here the range here, from 10.0.0.0 to this 10.255.255.255. So for, you can see also the total address space allocated for the reserve addresses. All right, so no router will forward a packet that has one of these addresses as the destination address, and the site must have only one single connection to the global internet through a router that runs the network address translation software, which we will learn in another part of chapter 6. Okay, for hybrid network, it allows an organization to have its own private internet and at the same time access to the global internet. So intra-organization data is routed through the private internet, and inter-organization data is routed through the global internet. Okay, so it basically has privacy in intra-organization data exchange, and at the same time it needs internet for the data exchange with other organizations. Okay, basically the organization have both global and also private addresses. If you can see here, an organization with two sites uses router R1 and also R2 to connect the two sites privately through a leased line, and also it uses router R3 and R4 to connect the two sites to the rest of the world. And the organization uses global IP addresses for both type of communication. Okay, however, packets destined or intended for the internet recipients are routed only through routers R1 and also R2. Okay, and routers R3 and also R4 are for the packets intended for the outsiders. Okay, which is not from both these sites. Okay. Okay, so now we come to virtual private network technology. So if we have learned about private network before, we understand the architecture. Okay, we can see that a private network can be very costly as the institution needs to purchase, install and maintain its own physical network infrastructure. So the solution here is to use VPN, okay, or virtual private network. Okay, so instead of deploying and maintaining a private network, a costly private network, many institutions now create VPNs over the existing public internet. So with a VPN, the institution's inter-office traffic is sent over the public internet rather than over a physically independent network. But to provide confidentiality, the inter-office traffic should be or needs to be encrypted before it enters the public internet. Okay, so basically for VPN, it uses global internet for both intra and also inter-organization communication. Okay, it is we can say that VPN is private but virtual. Private because it guarantees privacy inside the organization. Okay, however, virtual because it does not use real private wide area networks. Okay, so network is physically public but virtually private. Okay, in essence, a VPN consists of a set of computers that interconnect by means of a relatively unsecure network, and it uses encryption and also special protocols to provide security. So in VPN, at each corporate site, workstation servers and databases are linked by one or more local area networks, which is under control of the network manager. Okay, and can be configured and tuned for cost-effective performance. Okay. And okay, we can see here an example of the virtual private network. So virtual private network technology uses ESP or encapsulated security protocol of the IPsec in the tunnel mode. Okay, so it allows the transmission between two computers across a shared or public internet network. Okay, in the manner of point-to-point private link. So the router at the border of the sending side here uses its own IP address and the address of the router at the destination site in the new datagram. Okay, and the public network here, the internet here, is responsible for carrying the packet from VPN server, for example here, to the VPN client. And outsiders cannot decipher the contents of the packet or the source and destination addresses. And deciphering means taking out the outer layer of security. It takes place at the VPN client here, which finds the destination address and will find the destination address of the packet and will deliver it to the final destination. Okay, so we will learn into details of the IPsec here, in the tunnel mode here in the next chapter. Okay, so basically to have this link, the data that needs to be sent here needs to be encapsulated with a header that provides the information for the packet to traverse across to the other end. All right. Okay, the common use of VPN, as we can see here in this example, the institution that consists of headquarters, a branch office, and also traveling salesperson, okay, that typically access the internet from their hotel rooms. So in this VPN, whenever two hosts within the headquarters here send IP datagrams to each other, or whenever two hosts within the branch office here wants to communicate, they will use IPv4 without the IPsec services. However, when two of the institution's hosts here communicate over a path that will use the public internet, and the traffic here will be encrypted before it enters the internet. Okay, so you can see here that it will be encrypted before it will before this packet enters the internet, right? So when a host in headquarters sends an IP datagram to a salesperson in the hotel here, the gateway router in headquarters converts this IP datagram into an IPsec datagram and then forwards this IPsec datagram into the internet. Okay, as you can see here, this is already encrypted. That's why it is secured payload. Okay, and it adds IPsec header. Okay, encapsulated within the new IP header. All right. So this IPsec datagram actually has traditional IPv4 header, so that the routers in the public internet here processes the datagram here as it were an ordinary IPv4 datagram. Okay, because for them this datagram is perfectly ordinary datagram. Okay, there's nothing like new or special with this datagram. However, the payload of the IPsec here includes IPsec header, which is used for IPsec processing, and furthermore, the payload of the IPsec datagram is also encrypted. So when the IPsec datagram here arrives at the salesperson laptop, the OS in the laptop will decrypt the payload and passes the encrypted payload to the upper layer protocol. Okay. We will see in more details in terms of the IPsec protocol here in another chapter. Right, so another common use of VPN, okay, for example, for remote access over the internet and to connect remote client to a private network. For example, now if I want to access some of the websites that are available within UTM intranets, so I have to use the VPN. Okay, the same goes for you as students when you want to access certain websites or certain sites on UTM websites, okay, that required VPN. So you will use this VPN technology. Okay, and another example is to connect computers over the internet. Okay, and it uses VPN to connect to a secured or hidden network. Okay, this is a common use of VPN. Okay. So some of the benefits here of VPN to organization, it reduces cost compared to the private and also hybrid network, and it provide remote access to its staff and clients. Okay, just like the examples I gave you just now, where I can access to some of the sites, some of the UTM sites using the VPN. So it proves to be very useful, especially in our current condition right now. Okay, and it has better security through the intranet because so back to why we need intranet here, because not all information that are available on UTM websites are supposed to be accessed by outsiders. Okay, meaning that it is for students and also for lecturers only or for staff only, right? So internet as the backbone of the company's network, okay, one of the benefits to the organization, and the setting up is easier than private network and also hybrid network. And for the clients, okay, reliability to access to the intranet. Okay, so I can access to UTM sites even though I'm not in Johor Bahru right now. Okay, data integrity, flexibility where users are able to access the intranet or any server remotely, even though if you are in outside of the country, in UK or wherever you are, you can still access to the information within the intranet UTM. Okay, privacy of the data transmission, and also client can save time in their traveling for long distance company. Okay, just like the salesman example that we have seen before. Okay, so now we go to the network address translation technology. Okay, we know that the problem of running out of IP addresses is not a theoretical one. Okay, it might occur at some point in the distant future. Okay, it is already happening right here and right now. So we also have learned that the long-term solution for the IPv4 address space is for the whole internet to migrate to IPv6 which has 128-bit addresses and also much more larger address spaces. Okay, if you can recall from the chapter 4 and also chapter 5. However, this transition is very slow. It will be years before the process is complete. Okay, so in the meantime, okay, we can use the network address translation. Okay, because the motivation here is the local network uses just one IP address as far as outside world is concerned, and range of addresses not needed from the ISP. It means that just one IP address for all devices. Okay. Okay, another motivation is we can change addresses of devices in local network without notifying outside world. Okay, so if we can have that, it's very useful to the organization. And it can change ISP without changing addresses of devices in local network. Okay, basically the flexibility of the addresses in the local network, and also whole private address space hides behind one public address. Okay, and the technology of NAT here, or network address translation, allows a private network to use a set of private addresses for internal communication and a set of global internet addresses for external communication. Okay, so the basic idea is for the ISP to assign each home or business a single IP address for internet traffic. Okay, let's see into details of the network address translation. Okay, this network address translation is used by a device, for example, firewall router here, or computer that sits between the internal network or local network, and also we call it home network, and the rest of the internet. So as we can see here, the private network here uses the range of private addresses. Okay, so if you see here 10.0.0.1 here, it's allocated for private network. Okay, so these are all private addresses, and the router here that connects the network to the global address uses one private address and also one global address. Okay, it means that this router have two addresses, one private and one global. And the private network here is transparent to the rest of the internet. And the rest of the internet here sees only the router here, or we call it NAT router, network address translation router, with the address 138.76.29.7. Okay, so all datagrams leaving local network will have same single source NAT IP address, okay, which is the address, however different source port numbers. And datagrams with source or destination in this network will have 10.0.0.4/24 address for source destination, which is as usual. Okay, let's see some details example here. Okay, all of the outgoing packets go through this NAT router or network address translation router, which replaces the source address in the packet with the global NAT address. And all incoming packets here also will pass through this NAT router, which replace the destination address in the packet with the appropriate private address here. So in this figure, all traffic leaving the home router for the larger internet will have the source IP address of 138.76.29.7, and all traffic entering the home router must have the destination address of this one. Okay, so in essence, the NAT enable router here is hiding the details of the home network from the outside world, and the router gets its address from the internet service provider DHCP server. And the router here runs the DHCP server to provide addresses to computers within the this control home network, right? And since all datagrams arriving at the NAT router from the wide area network here have the same destination IP address, the router here will use the NAT translation table at the NAT router that includes port numbers and also IP addresses to know and forward a given datagram to the internet. Let's consider the example in this figure. Suppose a user sitting in a home network here, behind host 10.0.0.1 here, request a web page on some web server which with port number 80 and also IP address 128.119.40.186. Okay, so the host 10.0.0.1 here assigns the random or arbitrary source port number 3345 and sends the datagram into the local area network. right? So the NAT router here receives the datagram, generates a new port number here, okay, which replaces the 3345 here, generate new port number of 5001 for the datagram, replaces the source IP address here with the wide area network site IP address, or with the global site of IP address 138.76.29.7. Okay, basically this router change the source of the IP address and also change the port number. However, the destination here is still the same. Okay, so it replaces the original source port number with the new port number 5001. So when generating a new source port number, the NAT router here can select any source port number that is not currently in the NAT translation table. Okay, because a port number field is 16 bits long, then the NAT protocol here can also support over 60,000 simultaneous connections with a single wide area network site IP address for the router. And NAT in the router here also adds an entry to its NAT transaction table. So you have to be able to understand this NAT transaction table and also to read it. Okay, so here at the NAT transaction table, okay, at the wide area network site, or means the global site address, okay, it puts this address, the global address, and also the new port number that it has replaced the old one. Okay, so the old one means the private network part of the local area network site. Okay, so it has original source IP address and also source port number. Okay, so the destination, once it receive this datagram containing the HTTP request here, because the original port number here is 80, it does not aware that this request has been manipulated by the NAT router. Okay, so it will respond with a datagram whose destination address is the IP address of this NAT router, and also whose destination port is 5001. Okay, so when this datagram arrives at the NAT router, okay, the router indexes the NAT translation table using the destination IP addresses and also destination port number to obtain the appropriate IP address. Okay, using this NAT translation table also, the router can obtain the destination port number, okay, which is 3345 for the browser in the home network. Okay, and then the router then rewrites the datagram's destination address and its destination port number using the original or the LAN site source IP address and also port number. Okay, if you see here, NAT router changes the datagram destination address from the global address to the local address. Okay, and also from the 5001 or 5001 port number to 3345. Okay, and forward the datagram into the home network. Basically, you need to understand this network address translation and how to read from the NAT translation table. Okay, however, even though it has enjoyed widespread deployment in recent years, there are some issues with network address translation. Okay, because the IETF community argue that, for example, address shortage should be solved by IPv6. Okay, means that routers shouldn't manipulate with the IPv4 address. Okay, and also routers should only process up to layer 3. Okay, and they also argue that this NAT protocol violates the end-to-end argument. It means that hosts should be talking directly with each other without interfering nodes that modify IP addresses and also port numbers. Okay, and also they argue that port numbers are for addressing processes, because remember that we have learned before in chapter 2, the use of the port numbers are for the addressing processes and not for addressing hosts. Okay, and also another issue with NAT is it interferes with P2P applications. Okay, because the essence of the problem is that if a peer is behind a network address translation, it cannot act as server, and also it cannot accept TCP connections.